Hello dear students, today we are going to see the subject Mechanics of Solids. The subject code is 1625303. If you will see the subject Mechanics of Solids, it is also known as Solid Mechanics. And the definition says like this: it is the study of the deformation and motion of solid material under the action of loads. Mechanics of solids comes from mechanics because mechanics is subdivided into three parts. The first one is engineering mechanics, which you studied in first year. Engineering mechanics totally tells us about mechanics of rigid body. The second one is mechanics of solid, which you are studying now. Mechanics of solid tells about mechanics of deformed body. And the third one is mechanics of fluid, which you will study in fourth semester. It will tell you about mechanics of fluid. So in this lecture we will mainly discuss about mechanics of solid, which is our subject. If you will see our subject, there are totally 8 units in our subject. And the first unit name is mechanical property of material and simple stresses and strains. Once again I will repeat. Our first unit name is mechanical property of material and simple stresses and strains. If you will see mechanics of solid subject, it is used in various departments such as civil, aerospace, nuclear, biomedical, mechanical engineering and geology. So we are going to study the important subject which we can use in various form and various aspects. My name is Sudhir Kumar, a lecturer in James Polytechnic College from Mechanical Department. First of all, we will see what are the content of the lecture. That means what we are going to see in today's class. The content of our lecture is, first one, types of loads. In types of loads, we will see what is axial load, what is transverse load, what is torsional load. Then after seeing the loads, we will see what is a stress, a strain, Hooke's law, modulus of elasticity or Young's modulus, and the last one, change in length or axial deformation. So mainly in today's class we are going to see these topics one by one. Loads. The externally applied forces are termed as loads. Actually, if you will see, loads are the main causes for motion of any object, or loads are the main causes for deformation of any object. There are three types of loads. First one is axial load, second one is transverse load, and the third one is torsional load. First we will see what is axial load. So axial load is the types of force applied along the axis line. This is our shaft, understand? This is our shaft and this is our axis line for the shaft, understand? So the force which we are applying along the axis line, this is P, na? P is force. So the force which we are applying along the axis line, so these types of load is known as axial load, understand? Now we will see what is transverse load. So transverse load is the load applied perpendicular to the longitudinal axis line. That means we are not going to apply the force along the axis line. In this transverse load, we will apply the force perpendicular to the longitudinal axis line. That means we are going to apply the load perpendicular to the axis line. Understand, this is our beam. So we are applying the load perpendicular. So the definition says like this: transverse load is the load applied perpendicular to the longitudinal axis line. Understand? This is very simple diagram. Understand? If they will ask in exam, you have to draw this diagram and write the simple definition. Understand? The next one is torsional load. This is our figure. Torsional load means there will be two forces. Understand? One force will be in another direction and another force will be in another direction. The definition says like this: torsional load causes twisting action of material. Yeah, that is true. If you will apply torsional load means one force will apply by this side, another force will apply by this side. This will cause twisting action of material. It will twist the material. Understand? And the pair of external force result in twisting action of couple is due to torsional loading. Understand? You have to draw this diagram. This diagram is very easy. Next one, we will see what is stress. This is very important topic, dear students. Stress and strain, because one question will surely comes from stress and strain. What is stress? Stress is defined as the internal resistance offered by the body when it is subjected to external force. Understand? If we are applying any force on particular object, understand? If we are applying any force on particular object, it will deform, but the internal resistance will try to protect it from deformation. So the internal resistance offered by the body when it is subjected to external force is known as stress. If you will see, stress is expressed mathematically as force per unit area. Force per unit area means Newton per meter square and denoted by sigma. Understand? And the stress is also called as normal stress or direct stress. This is the formula. Sigma is equal to P by A, where P is normal force and A is equal to cross sectional area. Understand? Once again I will repeat. What is stress? Stress is defined as the internal resistance. Suppose that if we are applying any force on particular object, the object will deform, but internal resistance will not allow the object to deform. Understand? That internal resistance offered by the body or object is known as stress. So what is the stress formula? Sigma is equal to P by A. We will go to next slide. If you will see the unit of stress is Newton per meter square. Why Newton per meter square? Because stress is equal to force by area. The force unit is Newton and area unit is meter square. That's why its SI unit is Newton per meter square. And Newton per meter square unit is specifically called as Pascal. Newton per meter square is also known as Pascal, and the bigger unit of stress is megapascal. Here it is written 1 megapascal is equal to 10 to the power 6 Newton per meter square. So here are some points which we must see. Understand? 1 Pascal is equal to 1 Newton per meter square. That's why Newton per meter square is equal to known as Pascal. 1 kilopascal is equal to 10 to the power 3 Newton per meter square. 1 megapascal is equal to 10 to the power 6 Newton per meter square, and 1 gigapascal is equal to 10 to the power 9 Newton per meter square. Understand? Actually, these things you have to remember during solving the numerical problem. Understand? So if you will remember one line, this line, then automatically you can remember all the line. That means 1 Pascal is equal to 1 Newton per meter square. You have to remember, always keep in your mind. The second one is strain. We are going to see strain. Already we have seen what is stress. Stress is equal to simple. Sigma is equal to P by A. P by A means Newton per meter square. Now we will see what is a strain. Already you must have studied in first year. What is a strain? Change in length by original length. That means the ratio of change in dimension to the original dimension is known as strain. And it is denoted by a small letter E. And if you will see, mathematically it is expressed as change in dimension divided by original dimension. It has no unit because see, change in dimension unit will be, suppose that meter, and original dimension unit will be meter. So meter will get cancelled. Understand? Suppose that change in dimension unit will be meter and original dimension will be meter. So meter will get cancelled. So it has no unit. Thus it is dimensionless. Understand? So this is a strain. Now we will see what is Hooke's law. Hooke's law is often asked in your examination. Understand what is Hooke's law? We will see the definition. Within the elastic limit, the stress is directly proportional to a strain. Understand? Within the elastic limit, one thing you have to always keep in your mind. Within the elastic limit. That means if you will go beyond the elastic limit, it will breaks. Understand? So within the elastic limit, the stress is directly proportional to a strain. That means sigma is directly proportional to E. So sigma is equal to K, where K is the proportional constant. Understand? K is the proportional constant and called as modulus of elasticity E or Young's modulus. So sigma is equal to, we can write E, capital E into a small e, where sigma is equal to stress, capital E is equal to modulus of elasticity or Young's modulus, or a small e will be a strain. Understand? Where constant E is the modulus of elasticity or Young's modulus. Now again we will see what is modulus of elasticity or Young's modulus. So the ratio of axial stress, that means whether it will be tensile or compressive, doesn't matter, to the corresponding axis or axial strain, tensile or compressive, is known as modulus of elasticity. That means the ratio of axial stress to the axial strain is known as modulus of elasticity. It is denoted by capital letter E and its unit is Newton per meter square. So mathematically it is expressed as E is equal to axial stress divided by axial strain. So see, listen, one thing you must keep in your mind. The stress and strain may be tensile or compressive. Understand? So capital E is equal to sigma divided by a small e. So sigma is a stress, E is a strain, and capital E is Young's modulus or modulus of elasticity. Now finally we will see change in length, or we can call it as axial deformation. How it will change in length. So already we know the formula, sigma is equal to capital E into a small e. Understand? So we can write as capital E is equal to sigma by E. Why we can write? Because if E will come this side, then it will get divided by, because it is multiplied here, na? So here sigma divided by a small e. Understand? And already we know that one formula. What we know that formula? Sigma is equal to P by A. That means stress is equal to force by area we know, and one more formula we know. Strain is equal to change in length by original length. Understand? So if you will substitute these values, if you will substitute these values in this equation, then what we will get? E is equal to P by A divided by change in length by original length. Understand? Change in length by original length. So we are sending these things, this thing this side and that thing this side. So if you will do like this, then what will come? Then finally we can see change in length by original length is equal to P divided by AE, where A will be the area and P will be the, what will be the P? Force, or we can say load. Understand? So this is our change in length or axial deformation equation. Understand? I hope you all must have got a clear concept about the following terms, which are described below. Types of loads, which we have seen. What is loads? The load is cause for the motion of the object, or the loads are the cause for the deformation of the object. It may be axial load, transverse load, or torsional load. Understand? The second things we studied is stress. What is stress? Stress is sigma is equal to P by A. That means force per unit area, and its unit is, force unit is Newton per meter square. Understand, students? Okay, I will erase it. Then next things we studied is strain. What is strain, dear student? Strain means change in length by original length. Change in length by original length. That means, first of all, we will see strain is denoted by a small e. A small e. A small e is equal to change in length by original length, dl divided by L. That is called as strain. And strain is dimensionless. Why? Because strain doesn't have any unit. Why? Suppose that this length, this is 10 meter, change in length is 10 meter. Suppose that this is a bar. If we are applying any load, it will deform into, this is 10 meter. Understand? This is 10 meter length. So if you will apply load, then it will become 11 meter. Understand? Length. So change in length, that means 11 meter divided by original length 10 meter. So what will happen? Meter, say meter will cancel. Understand? That's why it doesn't have any unit. So a strain is unitless, or we can call it as dimensionless. Understand? Now I will erase the students. The next things we have seen is Hooke's law. The next things, modulus of elasticity or Young's modulus, which is denoted by capital E. And next things we have seen is change in length or axial deformation, DL. Dear students, if you are having any types of problem while seeing these videos, you can directly contact me through WhatsApp, or you can contact me in Gmail. I hope you all have understand this lecture in an effective manner. Okay, we will meet next week with doubt class. Okay, thank you. So further, if you want to collect more information about the particular topic such as stress, strain, Hooke's law, modulus of elasticity, Young's modulus, in any topic, if you want a clear concept, then you can refer these books. Understand? The first book is Strength of Material. The author name is Dr. R.K. Bansal and the publication name is Dhanpat Rai and Son. The second book is Mechanics of Solids. by R.S. Khurmi. Publisher name is S. Chand. Understand? So I will suggest you especially R.S. Khurmi book. Why? You know, in R.S. Khurmi books you can get a clear concept. Understand? See, one thing I will tell you, some books will give you only theory parts, but this R.S. Khurmi book will give you theory as well as numerical parts. So once if your theory will get clear, then easily you can solve numerical. And once you solve or once you able to solve numerical problem, that means already you are having a good concept about the particular topic. So these are the reference which I have also taken. So you can refer these books for further information. Okay, thank you. I hope you all must have understand these slides or this PPT in an effective manner. I hope as I taught you via this PPT, I will get the same response from you. Actually, this was our first lecture, lecture 1, simple stresses and strain from mechanics of solids. So guys, first things I will tell you, you should always remember your subject name, man. Mostly if I used to ask from my student after first day of my lecture, second day they are forgetting everything. So you must keep one thing in your mind. What is your subject name? So your subject name is mechanics of solids. I hope you all must have understand simple stresses and strain in an effective manner. Thank you. I am Sudhir Kumar, lecturer, James Polytechnic College from Mechanical Department.